A number of students have also asked me for a little bit of help on that normal worksheet, specifically the stuff on the back page, the tricky inverse questions. So the tricky inverse questions, let me open up that normal worksheet. Boop. The tricky inverse questions have you move through the series of 2 steps. Your first step is that you're going to go ahead and find a z-score using an inverse calculation, and then you're going to use the inverse formula to figure out whatever your missing variable is. So the way I would do this if I were you, so let me go ahead and show you the worksheet so that we have that. We'll just tackle the very first question on the worksheet. Get myself some annotation tools. It'll take me a second. Yeah, actually let's do number 3 because I think that one is one where we tend to have more problems. I've seen more errors on number 3. So first thing we should do on any normal question, draw a picture, because if we draw a picture, that will guarantee that we get some points, whether or not we get anything else right. So as we read through this, bloop, bloop, we see, I'm sorry, I'm trying to get my annotate tools. It just takes me a second. These nice pauses are really helpful for everyone, I know. All right, so there we go. Now I got to draw. For some reason, it's defaulting to white, which is not a color that will be useful. So if I were to use this, there's my pen. We would be drawing a picture. Oh, that's not my drawing. This is why I was concerned. Haha. We'd be drawing a picture. We know this is a normal distribution because it says normal. It's distributed with a mean of 11. And then we're told 10%. That's one way we know that we're in an inverse question at all. We've been given the answer. Of cars sold at this dealership require major repair within 6 months. What is the standard deviation? So this is another way that we realize right away that we're doing a tricky question is I'm being asked for the standard deviation. And typically when we do these normal questions, we have the mean and standard deviation and we have everything we need to plug into StatCrunch. So let me give us some steps here. First, let's draw a picture. Let's finish drawing our picture. We don't know necessarily, within is a really hard keyword to figure out where that 10% goes, but we do know that this is within 6 months. So 6 has got to be here. Now there's only one place and we realize, oh, within would mean that it has to get repaired before 6 months has even happened. So this is 10%. So the first step, like I said, we need a z-score. For z-scores, you must use a mean of 0, and a standard deviation of 1. It doesn't matter that we know the mean is 11. We want a z-score, and z's come from the standard normal with a mean of 0 and a standard deviation of 1. And this is where we're going to use StatCrunch. In all of my other videos, of course, I use a graphing calculator, so I want to show you what this looks like without one. So I'm going to go to StatCrunch. I'm going to leave all my writing there on the screen because I don't want it to go away. I'm going to sign in to our account. Cool, and you guys should just save that password so you're not retyping it in. There's no reason to not save it. And we're going to open StatCrunch. And I want to do a calculation. So I'm going to Stat, Calculator, and we're doing all the normal stuff. So let me squeeze this over here into this corner. It defaults to a mean of 0 and a standard deviation of 1, which is exactly what we want for a tricky inverse question. It's already shaded in the left side, which is what we want on this particular question, so I'm not going to change this to a greater than. That would be if I shaded the other side. And I don't know what my cutoff is. I don't know what this is as a z-score. I know what it is as a month of a car and how long it takes to be repaired, but I don't know its z-score. I know that z-score is negative because my value is below average, but I don't know what it is. So I'm going to go ahead and enter my 10%, 0.1. Since it's an inverse, I'm giving the outcome, that percentage, that probability on the other side of the equals. I press compute and it tells me here is my z, negative 1.2816 if I wanted 4 decimal places. Z-scores are the one time you're given my blessing to go ahead and round to 2 decimal places, because if you were using the table in an old school class, the best you could do in the table is 2 decimal places. So I'm going to be lazy and I'm going to go ahead and use just 2. So now we know, oops, I need to get my drawing tool back. Now we know that our z is equal to negative 1.28. And we're ready for step number 2. Step 2 is to use x is equal to z times our sigma plus mu. We get our cutoffs, that's 6, by figuring out how many standard deviations we were above or below the mean. So we know, let me go ahead and use a different color for plugging in. We know our cutoff was 6, that was the observation. Our z-score we just found was negative 1.28. We don't have sigma, but we do have the mean of 11. So now we just do a little bit of algebra. Okay, so I lied before when I said that I was the easiest algebra because there's a little bit harder algebra here. We've got to subtract 11 from both sides, which is going to have us end up with a negative 5 is equal to negative 1.28 times sigma. Now I have to realize that that 1.28 is connected to sigma with multiplication. So I think it got a lot of people that we always were just using addition and subtraction, so they still wanted to use it here. We've got to divide. So our last step is to take 5 and divide it by that 1.28. So we get, I'm going to leave all this writing on the top of it, it's fine. If you wanted to, you could write negative 5, but I know the negatives are going to cancel because a negative divided by a negative is positive. So I just do this in my calculator, and I've got my answer. 3.9062. There we are, we're done. The only thing we need to do is make sure that we put units on it, because anytime we do an inverse question, we end up with units, and those units for mean, standard deviation, and the actual observation are all the same. So we're talking about months. So mean is 11 months with a standard deviation of 3.9 months, and we had an observation of 6 months. So hopefully that helps you out with the sort of order of operations and how that all integrates with the StatCrunch calculator if you are using that instead of a graphing calculator or the TI-36X.